So in the CCNA security, one of the first things that we talk about is what Cisco defines as the networking threatscape, right? When you take other classes like CISSP or CASP, which is the CompTIA, well, really kind of the most advanced CompTIA certification that you can get, a lot of the discussion is about the threatscape and what that threatscape entails. And we're going to talk a little about that. It's kind of a generic discussion, and it's an ever-evolving environment, right? The threatscape constantly changes. But the reality is that nobody is immune from any type of attack today. Attacks are becoming much, much more advanced. The tools are much more readily available. So networks have to be much more intelligent in order to prevent these different types of attacks. And quite frankly, a lot of attacks that occur today are zero-day attacks, attacks that haven't been predefined or that we haven't seen signatures of those different types of attacks in the past. Now, attacks themselves come from individuals with particular geopolitical objectives or certain goals or mindsets that they want to achieve. You know, maybe it's an attack on an individual or corporation, or, you know, some hacktivism type thing where we're trying to prove a point. Could be script kiddies. Yes, sorry, Sam, I saw your chat message there. We do teach the CISSP. In fact, I wrote our own custom CISSP course. It is death by PowerPoint, unfortunately. It's a 5-day class with over 1,200 slides of information, but it is a very, very in-depth course. And it does, I feel it does prepare you very well for to take that CISSP exam. So as I was saying, script kiddies, hacking groups, organized crime, and actually what's been in the news the latest, right? Nation states. You know, Russians, the Iranians, the Chinese, the North Koreans. Obviously, it's a completely different world today than it was in the 80s when you had that movie Sneakers and they were breaking into phone systems and whatnot, right? So it's changed quite a bit. All right. Now, in the context of the exam, and of course in the cybersecurity space, there are some terms that you should probably be aware of with regard to what's being protected in the environment. Like, for example, an asset. An asset is anything of value to the organization. And it doesn't have to be a physical asset, right? What else would be considered an asset to an organization that might not necessarily be a physical component? How about trade secrets or intellectual property, right? You know, processes or procedures that organizations use that make them unique in the industry, that give them a competitive advantage. Assets can also be technological, of course, servers and email and network devices and whatnot, but assets can also be personnel and people. So an asset is anything of value to a particular organization. A vulnerability is defined as a weakness which allows an attacker to reduce the system's information assurance, right? The intersection of three elements: a system susceptibility or flaw, right? And what would be a system susceptibility or flaw? Typically that comes from poor code versions, poor software execution. It could be from poor implementation of security features on the system itself, like poor patch management, invalid or incomplete configurations on your firewall, out-of-date virus definitions or whatever. And the attacker then can access that particular flaw and exploit that flaw to gain access to the system or resources or whatever they're looking to do, right? So a vulnerability is anything that could potentially cause harm to the system, and that's what attackers look for. An exploit is whatever an attacker might use to facilitate a particular attack, right? Whether it is a tool that the user uses to gain access to a system, a social engineering exploit because your staff isn't trained in in all aspects of security, and they're susceptible to social engineering attacks and so on, right? A threat, an event with a potential to cause harm, right? Now, what is the difference between a threat and a risk? Because if you think about it, those two terms are very synonymous with each other, at least generically speaking, right? A threat and a risk kind of sound like the same thing. All right, well, let's see what risk says. The likelihood that a threat using a specific attack will exploit a particular vulnerability. All right, so what does that mean? A threat is an event with the potential to cause harm to a system, whereas a risk is the likelihood that that event would occur. Right? It's kind of like saying, yes, we know that there is a vulnerability in Windows XP. And there's a lot of risk if you actually have Windows XP systems. But if you don't have Windows XP systems, you don't really have the vulnerability, right? And the threat doesn't really exist. I mean, the threat exists against the operating system, but your network is not vulnerable to that threat because you don't employ that operating system. That makes sense. The other aspect of that is, and this has to go with deal with insurance as well, is the magnitude of the likelihood that you're going to be attacked, right? Big businesses, big banks, organizations that get a lot of attention in the media, they're going to be much more likely to be attacked than thinKtank, right? In fact, most people probably don't even know who thinKtank is. But the threats might be the same. I might be running the same systems in my network that Bank of America is running in their network, but the likelihood or the vulnerability of my system, we have the same threats, but the likelihood that an attack is going to occur on my system is less than their system, right? And that is simply because people don't know who we are. And you guys know who we are, but and so on. So, and then, of course, the last aspect would be a countermeasure or safeguard. Anything that I implement, of course, to protect the system from risk, from threat. We're going to talk a little bit about later on about different risk assessment techniques, quantitative versus qualitative risk assessment techniques. Now, as far as countermeasures go, there are generally three classifications of countermeasures that we can implement. Right? And let's see if I can remember all three of them. Obviously, we know that there are technical controls. Right? Technical controls would be what? In regard to a countermeasure, what would be an example of a technical control that would provide me the ability to reduce my risk footprint? Policies and procedures would not fall under technical control. Firewalls would fall under technical control. Right? Multi-factor authentication would fall under technical control. Operational controls and administrative controls would include things like policies and procedures, right? And so we'll see some of that. And then we also have preventative controls, and we have reactive controls, and monitoring controls, and so on. But we'll talk about that a little bit later. And those are the kinds of things that you get heavily involved in the CISSP as well. All right. This class is mostly technical and focuses, of course, on technical aspects. But we do, in this initial chapter, do talk about some of these other concepts. All right. The stages of an attack. Phase 1, reconnaissance. Right? Internet searches, social engineering, dumpster diving, domain name management searches, services, intrusive, non-intrusive network scanning, and so on. Reconnaissance is the act of going out and discovering information about a particular network, right? I was just in the process of kind of putting together, we're doing GIAC classes now as well, and one of the classes that we're doing is a GSEC class, and talks about all of these different stages of an attack. And so we're looking at a bunch of different tools and kind of incorporating those tools in the class. But a reconnaissance attack is anything that allows you to gain information about a system a policy, a procedure, the personnel, an organization, without actually penetrating the systems, without actually disrupting operations of the system, and so on. So, and you guys know some of the tools that you might some of the tools you might use to do that, right? For example, you might use Nmap to do some port scanning or ping sweeps, right? Now, that kind of falls under phase 2, scanning tools and scanning the network, but they're non-intrusive tools, so they could be considered as part of reconnaissance. What might be some other examples of reconnaissance attacks? When it comes to networking and it comes to, IT. Port scan, right? We just talked about that, right, with Nmap. How about who-is lookups, right? Going out to the web and looking up a company on the web, trying to find out how many employees they have, how much revenue they have, what they manufacture, if they're involved in lawsuits, if they have patents or if they have intellectual property or trade secrets, right? Trying to disclose or discover personally identifiable information for employees. If they have vulnerabilities in their implementations where they recently hacked and so on. As a person, an individual trying to discover information, you might use something like Spokeo. Spokeo is a website that allows you to gather people's internet footprint, essentially, what their social media presence is, and where they live and what their income is and how many, if they've been married or not married or whatever. These are all reconnaissance type things. We're not necessarily going in and penetrating a system or breaking into a system. There is a website. In fact, let me pull it up here real quick, that you can go to, and let me show you this website. It's called sectools.org or sectools.com, either one you want to go to. And the nice thing about this particular site, okay, is it provides all of the open tools that are available for performing these functions. But what's funny about this particular site is they actually have all of the personnel that use this site, all the people that are members of the site and whatnot. They rank the tools. So like every week you get a ranking, almost like a ESPN football ranking for the college football program, and it will tell you, which tools are the best. So Wireshark is listed as number 1 this week, and it was number 1 last week. Metasploit went up 3 spots to number 2, and so on. And you can download these tools and utilize these tools. The site goes through and describes how all the tools work. And you can go in here and you can download the tools. They have all the different operating systems. They obviously provide descriptions on how the tools are used. There's even some videos on using these tools to perform penetration testing, vulnerability scanning, and so on. Now, these tools are that are available on this site are, they cover multiple aspects of the stages of an attack. They're not all reconnaissance tools. Some of the tools can be used for scanning. Some of the tools can be used for gaining access. But it's a nice repository of all that information. So a scanning attack, we're looking for open ports, open services on a device, looking for vulnerable applications based on their software version or firmware version or whatever it might be, looking for weak protection for data in transit, whether it's using DES or some other weak encryption algorithm, or if it's using some sort of weak hashing algorithm like MD5 without HMAC or something like that. So a scanning tool is not necessarily, again, a process, or the scanning phase is not a process where I'm trying to gain access to systems. I'm trying to identify vulnerabilities so that I can really kind of look at what all my threat vectors might be for those particular systems, and I can start organizing my exploits to gain access to those systems, which would bring us to phase 3, gaining access. The goal here is to either extract valuable information from a system or attack a system, right? The most common form of attack in networks today is what? DDoS, right? Denial of service, right? Or distributed denial of service attacks. Denial of service attacks are the most common because the goal of those types of attacks is to interrupt services so that those services are no longer available to their clients or to hurt the reputation of a business. But the reason why denial of service attacks are so easy to facilitate is because we're taking advantage of things that the system is already designed to do, right? A web server, for example, is designed to listen for TCP send requests on port 80. So a TCP send flood attack on port 80 to a web server is not that difficult to do, right? We stop those denial of service attacks with IPSs or IDSs looking for anomalous behavior and so on, all right? Once you gain access, you can either escalate your privileges, you can steal information, you can modify information, and so on, all right? The fourth phase is to maintain that access. Don't get caught, so you can maintain access to that system, and if you need to continue to access the system for other information or whatever, as long as you can maintain that access, you have access to those resources. And then finally, the last thing is covering your tracks. Not so much because you don't want to get caught, right? And that's obviously one of the things that you're kind of concerned about. But the other thing is you want to be able to continue to use those exploits. And if you don't cover your tracks, you can expose the tools and the techniques that you use to gain access to a system, which means those tools and techniques become ineffective. All right. So something to consider. I don't know that you guys will be tested on these 5 stages of an attack. They used to test on that in the exam, but all right. A denial of service attack is an attempt to make a machine or a network resource unavailable. Right? Consume resources, whether they're software resources, memory resources, network bandwidth resources, whatever it is. But the overall goal of a denial of service attack is to try to make it so the system is unusable. Way back in the, well, not way back in the day, probably 4 or 5 years ago, there was a very publicized type of attack. AT&T was coming out with a new product. And to this day, I still don't know what that product was. But they were coming out with a new product. And so they bought, like, I don't know, a third of all the Super Bowl spots on during the Super Bowl, including some of the most prime real estate in that telecast. And it was one of those artsy kind of ads where they weren't telling you about the product. They were kind of capturing your attention. At the end of the ad, they had a website you could go to see what the product was all about. And it never worked. The entire time during the Super Bowl and like a couple of weeks after the Super Bowl, nobody could get to the website because it was being attacked by distributed denial of service attack, which means that they effectively lost millions, potentially tens of millions of dollars because their website wouldn't work, right? Now, these denial of service attacks can be intentional. They can also be unintentional, right? You know, it's kind of like you hear about the stories about how these businesses go on Shark Tank. And the night that Shark Tank airs, their server crashes because everybody's trying to go to their website to look at their product or to buy the product, right? In the concept of networking, denial of service attacks are very prevalent, or they can be prevalent. We talked about this all week in the CCNA. What types of protocols are susceptible to denial of service in most networks? Not specific protocols, but in general, what types of protocols are susceptible? Any protocol that's dynamic in nature. DHCP, broadcast-based, dynamic. ARP, broadcast-based, dynamic. Right? Routing protocols, multicast and broadcast-based, but dynamic. So any protocol that relies on the dissemination of information to the masses by using either multicast or broadcast is highly susceptible to a denial of service attack. We're going to talk about, from an application perspective, a TCP SYN flood attack, right? An ICMP flooding attack, what we call the ping of death, or even Smurf attacks. We'll take a look at a Smurf attack a little bit later on. So those little blue guys, they run up to you and they kick you in the ankles, right? But yeah, exactly. But there are many, many different types of attacks, and we'll get into some of the technical controls that we would use to mitigate these vulnerabilities and mitigate these exploits. All right. A distributed denial of service attack, of course, it's a more common denial of service attack. Why? It's relatively simple to deny or to prevent a denial of service attack. Why? Because it's coming from an individual host. So if I see a single host sending me 1,000 TCP SYN requests, right, that's going to be much easier to spot as an anomalous behavior or an anomaly than if I see 1,000 hosts trying to send me one TCP SYN request, right? So a distributed denial of service attack is very much the same as a regular denial of service attack. The only difference is that the attack is coming from multiple sources. And this is typically done with something called a botnet, right? Oftentimes when computers get infected with malware or a virus, it's not necessarily to gain access to information on that particular computer. It's to install software that allows an attacker to control that machine to establish some sort of denial of service attack, right? They'll become zombies in your botnet, and then those zombies run these little batches of programs in the background to attack other computers, all right? There are two types of denial of service, distributed denial of service attacks. A network-centric attack, which overloads services by using up bandwidth or network resources, and application layer attacks, where we try to overload the services or a database with application calls, or I guess you could potentially say like a TCP SYN flood attack could be application-based, but most people classify that as a network-based attack because we're trying to attack, even though it's application-related, it's still at that transport layer, which kind of falls below the application layer. All right. A Smurf attack. Not easy to facilitate, by the way, and not as prevalent as we saw back in the in the day. But a Smurf attack is a distributed denial of service attack. We take a large number of ICMP messages, right? Packets that get sourced from the broadcast address of the subnet that the client belongs to. Okay. So when you ping a broadcast address, everybody within that subnet is technically supposed to respond to that ping. All right. So if I know a client is in the 10.1 network, for example, and in fact the victim in this case is 10.1.1.5, if I ping that client's subnet and I ping a directed broadcast address, 10.1.1.255, for example, but I source the ping from the victim computer, then all of a sudden everybody on that subnet is responding to the victim computer and overwhelming the victim computer, right? Now, why is this type of attack not particularly easy to implement? You need to know the networks, and most routers, by the way, block directed broadcasts now. The way it's drawn in this diagram, we've got an attacker that's dialing into a network or coming in through a DS3 or a T1 or whatever it is that they're talking about on the internet or whatever. Obviously, in this case, with the advent of NAT and private addressing and public addressing, it's exceedingly difficult to create this this packet. Plus, how is the attacker going to ping the broadcast address of a network that it doesn't belong to, right? Because that ping is not going to get routed. It's not going to get routed to the destination, all right? So it's not an easy attack to facilitate. Most of the time, this type of attack would occur within the LAN. It's very easy to do if you're a member of the same LAN, right? You want to overwhelm a host? send a ping to the broadcast address of the network, and source that packet from the victim computer. In a LAN, that's extremely simple to do. All right? And by the way, the router's not even involved in protecting against that at this point, because it's all switched traffic. It's all a layer 2 switched instead of routed. So the way it's drawn on this diagram here doesn't really, it's not really, easy to facilitate. All right?
So if you're in the network, what's to keep the switch from routing the...
Nothing.
Or just send it back to the attacker?
The attacker is not the source of the packet, right? Remember, ICMP, at layer 2, it's a frame, but at layer 3, it's a packet, right? So the attacker, let's say I open up an application, I send out a ping. I'm pinging the broadcast address at layer 3, but I'm spoofing the IP address of the victim. Now, if you think about the way switch handles traffic, it uses frames, right? It uses the MAC address to forward frames, so IP address doesn't even come into play. So when the clients respond to the victim, they're either going to do, and this is even worse, they're going to do an ARP request to try and discover the victim. So now the victim is also responding to a whole bunch of ARP requests. Well, the attacker wouldn't in this case, because let me think about it. So
I guess the way I'm thinking of it is the attacker changed his laptop IP, but I guess he's not doing that. He's just creating a packet with a fake
packet. That's exactly right. Fake packet. His IP is not in the payload at all, right? So it hurts the victim in two aspects, right? The victim has to respond to all these ARP requests and then also respond to all these pings. And if you do a persistent ping, it could be pretty easy to bring down a system that way. So a botnet denial of service attack, the attacker obviously uses a command and control machine. This is just a visual representation of that concept. And then we're just trying to facilitate that attack from multiple threat vectors. And the idea here is that we're circumventing, IPSs and IDSs that look for anomalous behavior from one host, which might not look so anomalous if it's coming from multiple hosts in the network. Okay? Spoofing attacks are really, really prevalent as well in networks today. We talked about this in the CCNA class last week. You can get the new Kali Linux package that has a tool in it called Yersinia that allows you to generate all types of network traffic. CDP traffic, 802.1q tag frames, VLAN tags, spanning tree BPDUs, even DHCP messages, right? So a spoofing attack is any type of attack where the malicious party is trying to impersonate a device or a host or some sort of trusted component in the network, either for the intent and purpose of stealing information. We'll talk about things like DHCP spoofing, ARP spoofing attacks, and so on, router spoofing attacks, routing protocol spoofing attacks, or to poison information that the client might see. For example, if I do a DHCP spoofing attack, what's my goal? Ultimately, what do you think the goal of a DHCP spoofing attack might be? Starvation is a denial of service attack, not necessarily a spoofing attack, right? The goal of a DHCP starvation attack is to ensure that we're not allowing anybody to be able to access the network because they can't be assigned a DHCP address. Spoofing attack is different. Yes, exactly. Spoofing as the DHCP server, what would ultimately be my goal? It could be one of two things primarily, right? Either poison DNS, so I can do phishing and farming attacks, right, where I'm sending people to, a fake Bank of America website or whatever, fake Cisco.com website. Huh?
Fake Equifax site.
Yeah, a fake Equifax site. They got that $1.7 billion contract right after that with the government. Yeah. 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 But
create a man-in-the-middle situation.
Man in the middle, exactly. A lot of hosts, when they want to communicate, they have to go to their gateway. And gateway is one of the things that you get assigned from the DHCP server. Well, if I can insert myself as the gateway in your conversation, I can now capture your information, modify your information, possibly steal personal information, and I can even forward that information along to the real gateway, so you have no idea that that traffic is being intercepted, right? So you can poison DNS, you can poison your default gateway, or other aspects, you know, whatever domain name or whatever it is that might be assigned. MAC spoofing attacks, very similar in that we're trying to capture switched information that's supposed to be switched to somebody else. We're trying to capture it so we can spoof somebody's MAC address. All right. So, and you'll notice one of the things that's kind of a common thread with all of these different applications and services that they listed, they're all dynamic. DNS is a dynamic protocol. DHCP is a dynamic protocol. Routing is dynamic, and so on. All right. This is a pretty picture to describe what spoofing is. I don't think we need to really spend too much time on that. I think you guys get the idea. All right. Social engineering. Very, very interesting concept in the world of hacktivism and hacking and cyber threats and whatnot. Social engineering, you guys know what it is, and there are many, many, many different types of social engineering techniques that are used, right? Baiting is perfect. There's a show that I watch, and I'm sure some, because we're all nerds in here, we all watch it, and it's called Mr. Robot, right? You guys watch Mr. Robot? And one of the techniques that they used was a baiting technique to be able to. They were trying to gain access to a computer system in a prison. Of course, the prison has high levels of security. It's very difficult to get into the inner sanctum of a prison. So what they did is they put some virus software on some USB drives, and they dropped about 100 of them in the parking lot where the security guards are parked. And sure enough, one of the security guards picks up a USB drive, takes it into the office at work, and plugs it into the computer, and now the computer's infected, and they get access to the system, right? That would work, wouldn't it? I mean, it really would. Whether you're trying to break into a bank or a system like that, or you're just trying to get into somebody's computer, how many people, if you dropped a bunch of USB drives around the airport, how many people do you think would actually pick one up and plug it into their computer? Quite a few. Yeah, quite a few. All right. I've heard of that show, Bernard, Silicon Valley. I haven't seen it. Has anybody watched Silicon Valley? Is it done well? I don't know if it is or not. 80s, yeah. Halt and Catch Fire. Halt and Catch Fire? Oh, yeah. Technically accurate, very funny. Okay, I'll have to check it out. A IT show that's funny. Wow. Like the It Crowd. The It Crowd? Yeah. Yeah, the It Crowd or IT Crowd, whatever you call it, that British comedy. That's pretty good. Right? So social engineering, as you guys know, psychological manipulation of people, right? And it really kind of happens all the time. All right? There was a scenario where I live in Santa Clarita in California, and there's, of course, LA. There's filming studios all over the place in LA. There happens to be a backlot in the hills of Santa Clarita that's owned by Disney that is closed. It's closed. You can't go into it, and it's off this dirt road. They film a lot of westerns out there, and there's a lot of Western movies were filmed in Santa Clarita because of the landscape. So we drove down that dirt road, and there was a security guard. They don't have an official gate, but they had a security guard waiting at the front. And I saw a sign as I was driving down that had ROAR. It stands for some sort of production thing or whatever. And I saw a bunch of signs with ROAR, and it had arrows pointing down the road. And so we pulled up, and the guy says, yes, can I help you? I said, I'm here for ROAR. And he said, okay, have you checked in? I said, no, we haven't checked in yet. He said, well, the staging area is right over there. You need to go check in. So we go through. And then there was another security guard and stopped us and said, and we said, yeah, we're from war. We're just going over to the staging area to check in. And he was sitting right in front of that staging area. And he said, okay, you need to go into that trailer and sign in, and then you can go on the lot. So I parked. I walked around to the side of the trailer where the door was. I stood there for about 4 or 5 minutes. And then I walked back and got in my car. And I drove up. I gave him a thumbs up, and he waved me through, right? And we drove all the way through the whole lot. We were walking through all the sets and everything. And you know, that's social engineering, right? I mean, it's kind of a basic concept of social engineering, but it is social engineering. It's kind of like, I was reading an article online about this kid that was sneaking into all these events, right? He snuck into like the 7th game of the NBA Finals, and snuck into the McGregor-Mayweather fight and whatnot. Yeah, he dressed as a waiter one time. Another time he had a lanyard with a fake press badge, and he said the reason why he got away with it so much was he simply acted like he belonged there, and he was essentially, you know, taking advantage of janitors or people that were cleaning or whatever that wouldn't really scrutinize his credentials or whatever. But you know, and you guys know there are many other types of social engineering, right? Sorry? Scary? It is, right? It is, but just running up behind someone and the door is closed and say, oh. Right. Yeah, that kind of thing. Mm-hmm. They're already trying to get in. They're already done with getting in. Yeah. They're just trying to, yeah. Exactly. Yeah. Now, exactly. From a technical standpoint, social engineering can come in the form of, you know, fake emails. You guys have all seen these, you know, phone calls of people pretending that they're the IRS or whatever. There's another show that I watch on TV called American Greed. I don't know if you guys have seen it. It's on CNBC. Really, really good show, but it talks about all these scams, and most of them are Ponzi schemes, but every once in a while they have, you know, some, you know, internet fraud stuff on there or something like that. And, you know, there was one Jamaican scam the lottery scam, where the Jamaicans would call and say you won the lottery, but in order for us to release the funds, you have to pay taxes, or you have to pay this fee or that fee. And they scammed hundreds of millions of dollars from people, and they, of course, never sent any money back, obviously. So a phishing attack, social engineering attack, you get an email, looks like it's from a legitimate business. The most common you see, right, PayPal, eBay, right, where they want you to go log in. So you and I know, because we're networking folks, if I see a URL that says ebay.x.com, we know that that's not eBay, right? That's a subdomain, and some other proprietary domain that doesn't have anything to do with eBay, right? Tailgating, you guys know what that is. Shoulder surfing, of course, you know what that is. And quid pro quo, right? Obviously, we know what that is. You give me something, I'll give you something, and so on. Any other types of social engineering attacks that might exist? There might be authoritative social engineering attacks, where you might go to a location and say, hey, I'm from Comcast. We need to test your phone lines or your internet line, and to get by reception. I mean, there's all kinds of them. Yeah, exactly. He probably was an inspector, but yeah, I get what you're saying. All right. So phishing attack, the attacker poisons DNS or intercepts DNS. Oftentimes it might be just simply installing or changing the local host file on the host. So when they go to bigbank.com, it doesn't really go to bigbank.com. And the idea here is that we're trying to capture financial information, right? Logins, credentials, etc. That's why a lot of these sites now employ the use of multi-factor authentication, right? We'll talk about that. Actually, let's talk about that now, right? Obviously, an ATM, that's multi-factor authentication. By definition, what is multi-factor authentication? Okay, multiple factors of authentication. Yes, that is multi-factor authentication. Perfect answer. Right. Right. There's a way to identify your identity with something you know, something you have, something you are, right? And sometimes something you do, which might be kind of like something you know, right? Any authentication method that employs the use of one or of two or more of those is considered multi-factor authentication. You go to an ATM machine, it's multi-factor authentication. You have your card, you put it into the machine, and you have your PIN code, which is something you know, right? So a lot of these websites, a lot of these banking sites, and it's kind of annoying, but it ends up being required nowadays, require this multi-factor authentication, right? Because what do? They allow you to authenticate, but then they send you a text or an email that says, put in this verification code. Now, you might say, well, the verification code is something I know, but the text went to something you have, which is your phone. The text went to something you have, which is your email account. So that ends up being multi-factor authentication. All right? All right. So phishing, lots of different types of phishing. Spear phishing, targeted versions of phishing focused on a specific company or individual, either by using impersonation, personalization that would somehow tie to the intended victim, which indicates to the victim that this might be legitimate because they know personal information about me that they may not have known. Enticement, access control, bypass technique, email filters, antivirus, etc. Whaling, any type of phishing attack that looks to target big executives or CEOs or people in a business that have, you know, a significant presence in that organization. That's the whole Las Vegas term, right? The whale. They always want to bring in the whale, so that the big fish, yeah. Farming, redirecting websites traffic to fake sites by modifying either the host file on a victim computer or exploiting vulnerabilities in DNS by intercepting DNS queries and spoofing DNS servers, etc. All right? Watering hole. This is a pretty interesting concept. You want to attack a particular group or you want to attack individuals. One of the methods that you might use is a watering hole, right? So, for example, I am a member of several different Facebook groups related to certification. So if I was a bad guy and I wanted to attack individuals, I might go to that group, provide some sort of enticing thing related, you know, or something that people would be interested in specific to that group to get them to click on a link or download something. And that would be considered a watering hole attack because I'm targeting a specific group of people that are there for a reason. You know, that term comes from, obviously, animals coming together and drinking together. If you poison the water, you kill the animals, right? You don't have to go to every animal. You just poison the source, right? Vishing, using a telephone or to scam users. You would think that this would go away, but it doesn't. People still fall for it. The old IRS scams, right? The old Microsoft scams. How many of you guys have gotten the Microsoft support phone call before? Yeah, 3 times a week. Yeah. And then, yeah, it never changes. And then smishing, all right? SMS Trojans or SMS phishing. Haven't seen that too much. I mean, I've been spammed before with text, but. Yeah, I haven't actually. Yeah, I haven't gotten. Mostly, well, the phone ones, it's always either the IRS or Microsoft. That's the ones. I have never gotten the IRS scam one, but I've definitely gotten the Microsoft one before. You know. So farming, just a picture to describe what the farming attack looks like. It's, again, poisoning DNS, trying to redirect somebody to an invalid site. Password attacks, right? You know, obviously you guys know about password security. We're in IT. We know what password security is all about. There is a interesting concept to password security, though, that I want to show you guys. And it's called the password haystack. Let me pull that up real quick. Because there's a website that, if you just Google password haystack, and I'm not going to get into the specific details about this, but it's the very first link that shows up. So these people, I'm not sure if it's a person or individuals, that they came up with this this mathematical calculation to give you an idea of how strong your passwords are based on you know, whatever password you type in here, right? So if I type in password, for example, it tells me that my search space depth is 26 characters, which makes sense because I'm using the alphabet, right? Now, if I do a capital D, my search space character doubles because now I'm using uppercase and lowercase letters, right? And the other thing that they provide is they provide the work factor that's required to break this password. Now, what's interesting is that if it's an online attack, of course, it takes 17 centuries because you're only doing 1,000 guesses per second. But if it's an offline attack, 9 minutes, or if you have a supercomputer or array of computers, less than half a second, or a little bit more than half a second. Right? So obviously we know that password is not necessarily a secure password. But what's interesting is that if you simply add 3 or 4 characters, look at the change. And still, that somebody would look at that and go, that's not a secure password, right? But the work factor for fast attack scenarios went up to 5.75 centuries, right? And even just adding 1 dot made it days, but 2 or 3 or 4 dots up to 5 centuries. And now still 7 months if you're using you know, guessing 100 trillion guesses a second. So somebody might say, well, this password, Z4HY6%97, that password is more secure than password ... In actuality, it's not. It takes about 18.6 hours to crack that password versus password ...
I always show people that with password.
Right. Exactly. And they refer to this as your password haystack. On the page itself, we're not going to go through all of it, but they describe, you know, why this principle works, and from a computing perspective, why does it take much longer, you know, for seemingly a less secure password, right? So obviously there are many different options you can try. So I'm not going to waste your guys' time by talking about, you know, what you guys should do to secure passwords, because you guys know what's involved in that, right? You should have a minimum length. You should have, you know, a history. You should change your passwords. But the one thing that I do mention usually on this particular slide is, obviously there's a balance between having a password and a secure password policy to usability. Because you can get to a point where the security is so much that it becomes so inconvenient for the users that they end up breaking policy. They'll write passwords down on a sticky note, or they'll share their password with somebody, or whatever. All right?
Saying all those things, because if you make it too crazy too often, people tend to create patterns that if you find out one of their old passwords, for instance, you might be able to guess their current password because they don't deviate much from it.
Right.
So the new
And I'm actually kind of guilty of that.
I am too.
You know.
It's still like a 12-character or 16-character thing.
Yeah, but okay, you might add an exclamation, or you might change one character.
So the
Right.
new guideline is don't make people change their passwords that often, or at all until it's compromised, which I don't agree with. But
Right.
And let it be just a phrase or something. The longer the phrase, but the easier for them to remember, more personal. And,
They didn't have a complexity requirement either.
yeah.
Right.
I love my cats.
I mean,
It
that
sounds like,
would be good to use, and then maybe you don't change the password, just make it so that it's so hard, to crack that you remember it, but.
right.
The one that I always tell people to work with is, full sentences with like spaces and
Right.
and all that.
Passphrases, right.
Also, song lyrics.
Song lyrics, your favorite song lyric.
Yeah. Yeah, because obviously as the key space grows, whenever we talk about cryptography and cryptanalysis, we always talk about key space, right? Key space is the key, pun intended, to any security algorithm, right? And the larger the key space, seemingly the more secure the algorithm is, right? Okay. Reconnaissance attacks, we talked about. Reconnaissance attack is where you're trying to target a system or gain out information about a system using dig, NSLOOKUP, whois, ping sweeps, port scans, dumpster diving would be considered a reconnaissance attack. Even monitoring people's daily activities is considered a reconnaissance attack, right? And you see it in the aspect of physical security as well as IT security, all right? Buffer overflow attacks, right? Attacks against the way memory is allocated inside of a computer, right? We take advantage of a program that it's waiting for user input. Now, what does that typically mean from a program perspective? What's being allocated during that waiting process? Memory, right? Registers in a computer that's looking to store information that's being inputted into the computer itself. Two different types of buffer overflow attacks: a heap-based attack and a stack-based attack. So a heap-based attack, the attacker floods the memory space that's reserved for a particular program. But the problem with this particular type of attack is that memory that's allocated in a computer is actually secured. And there are, and I'm not completely versed in this, but there are restrictions on what applications can access what memory blocks in a computer based on values that are either one-time values or values that are generated for a particular application, right? More commonly, you're going to see a stack-based buffer overrun attack. The program's being exploited by using memory objects known as the stack to store user input, right? So that stack is empty. It's a temporary memory location. When the program requires user input, it writes a return memory address to that stack, and then the user input information is placed in there so it can be sent to the application, right? It's just the process of moving data from the I/O, right, the user I/O, to the application itself. In either case, and you're not going to be tested on buffer overflow attacks on the exam, but in either case, the goal is to crash an application or a system. Now, if you're using Microsoft, this generally happens without any kind of malcontent, right? It just happens by poor code design, right? So, yeah, buffer overflow attack. All right, man-in-the-middle attacks. Now, there are two types of man-in-the-middle attacks. You've got active man-in-the-middle attacks, and then you've got passive man-in-the-middle attacks. Both of them involve the user intercepting information, right? Now, passive man-in-the-middle attacks, the goal of that is for the user to be able to capture information, but not necessarily modify the information along the way. Right? So the way that we protect against a passive man-in-the-middle attack is what? It's called data in transit or data in motion. And what type of technique do we use to protect against those passive man-in-the-middle attacks? Encryption. Encryption. Confidentiality. Right? A passive man-in-the-middle attack, active man-in-the-middle attack is where the user is, or the attacker is trying to not only capture information, but modify that information and send it on its way, right? And of course, we can still use cryptography, specifically encryption, to protect that data from being disclosed. But then what else do we use to ensure that the data is not being modified? Hashing. And specifically, hashing with authentication, right? There's two types of hashing that are available. There's MD5, there's SHA, but then there's also MD5 and SHA with what we call HMAC, right? Which is a hashed message authentication code, but it has some sort of secret value that's put into that hashing process. We'll see that later on as we get into the cryptography lessons a little bit later on. Okay? So what is generally the goal of a man-in-the-middle attack? It's twofold. Either to steal information that I'm not supposed to see, or to modify or change information that's being sent in transit. Right? All right. And here's a pretty diagram that describes that process. The attacker is saying that 10114 is at MAC address D, which is the attacker's MAC address, and that's telling the host B, 10113 is at MAC address D. Of course, that's not the real MAC address of A or D, right? Excuse me, A or B, excuse me. So the goal is to get the switch to forward frames the attacker that it can either copy, modify, or whatever, and then forward it on to its destination. What kind of man-in-the-middle attack is this called? Anybody? Art poisoning. Isn't this art poisoning? Or, you know, it could be, well, it is art poisoning. I mean, technically, that's what it is. Whether it's gratuitously done or it's done dynamically through the art process, it is still art poisoning. Okay? Sorry about that. All right? All right. Malicious software. Now, generically speaking, anything that's malicious on your machine is malware, obviously, right? Malware stands literally for malicious software. So a Trojan horse, a virus, a worm, all of these can be considered malicious software or malware, right? You know, we see all kinds of malware today. Some of it can be relatively benign. You know, maybe the goal is just to put, you know, bring pop-up ads, you know, or hijack somebody's browser so that when they go to their browser, they get redirected to a page, and that's the only intent of that malware. And some of it can be much more intrusive, right? Sometimes you might not even know that it exists. The goal of the malware is to allow somebody to control your computer for a denial of service attack. All right? So a worm versus a virus. These terms kind of get interchanged quite a bit. What's the fundamental difference between a virus and a worm, though? Any ideas? Viruses usually embed themselves into an application. And you know, when you download a program or you download a file, you download iOS from Cisco or whatever, the virus is embedded inside of that application. Worms can be delivered the same way, but then they're self-replicating. You infect one computer, and then a worm will go out and utilize the network to copy itself to lots and lots of other computers, right? So a lot of people kind of look at these terms as the same, but usually viruses only spread through the proliferation of poor applications or an infected file or whatnot, where worms are self-replicating, all right? And of course, we know what the Trojan rabbit is. Reference, what movie? Come on. Monty Python, Holy Grail, remember that movie, right? Obviously, a Trojan horse, we know what that is, right? Malware disguised as something legitimate? Yes, exactly. Somehow I knew you would know that movie reference. So, all right. I guess what else could be considered kind of a Trojan horse? you know how sometimes, and my parents fall for this all the time, you go and download some application on the web, and it comes from a trusted site, or maybe not, SourceForge or something like that. So you download this software and you install it, and during the installation process, 3 or 4 other programs get installed, right? Now, that's illegal unless they have a disclaimer in the application that says accept or decline, right? And the accept is a big button, and the decline is a little tiny link on there that says, decline to install this application. Sorry? Right. Right. Now, that's not technically a Trojan, but, it's kind of the same thing. You're installing this one program without the idea that these other programs were being installed, Internet worms. I love the one, the Morris worm, right? It says here, one of the first computer worms distributed via the Internet also resulted in the first felony conviction under the 1986 Computer Fraud and Abuse Act, written by a graduate student at Cornell and launched on November 2nd, 1988 from MIT. This was actually this guy's graduate project. And he got arrested for it and put in jail. And then, of course, proliferation of a lot of different worms. NIMDA, of course, was a big one. MyDoom, Slammer, Anacornicova, etc. Conflicker was one. Stuxnet, that's another interesting one. So it was essentially where the United States government attacked Iran and destroyed a lot of their centrifuges that were used in their nuclear program by the programmable logic controllers that were installed in these centrifuges had a vulnerability in them. And all you had to do was flash an update to those controllers, and they would spin the centrifuges out of to the point where they would destroy themselves. Yeah. So that's kind of cool. All right. So the site that I told you guys about before, sectools.org, great website to go out and really kind of look at all the tools that are available today. Some of them are kind of script kiddie-ish tools, but some of them are really valuable tools, and they can provide a lot of useful information for you. Kali Linux, of course. Kali Linux is a package of tools that has multiple penetration testing programs, over 700 now, 600 when we put the slides together. And the idea with Kali Linux is that you can use that platform to perform vulnerability scans and assessments of your own network, right? And it includes Metasploit. It includes a whole bunch of password recovery tools. Yersinia is one of those tools that's part of Kali Linux as well. So you can attack CDP, spanning tree, DTP, which is the dynamic trunking protocol, DHCP, HSRP, a lot of network-based attacks. If you guys want to get, and you guys learned this in the CCNA class, the latest and greatest packaged Kali Linux, just go to osboxes.org. osboxes.org has all of these packages free for download. All right. Another organization, the Open Web Application Security Project, or OWASP. A lot of vendors, like Cisco, like Dell, like HP, are a member of this program. And the idea of OWASP, and you can go to their website as well, is to kind of provide a central channel for communicating network security and talking about businesses get involved in developing these ideas for securing the infrastructures and whatnot. So the idea here is that we have a community of professionals that can come together and identify, what the threatscape looks like today and how we mitigate a lot of those vulnerabilities and threats in our environments today. All right, so that concludes the first chapter. And now we'll go into the next chapter.